Okay, so in the next part of the question, we are once again working out one of these sort of wedge-shaped areas, and as we did earlier on in the worksheet, we're going to observe that this is the area of the whole sector minus the area of that triangle in the middle. This angle, because it's the same sector as the previous question, is 108. And I already know that the entire sector area is 30 pi, or you could express it as a decimal, of course. I know the radius is 10, so the area of this triangle is a half times 10 times 10 times sine of 108. And if I subtract these from each other, I'm getting this shaded area over here. So now it's just a case of plugging that into the calculator and you've got your answer. So I'll do that quickly now. And we're getting 46.7 centimeters squared. Now in this question we have to read the information carefully and look at the picture carefully. This line up here to Q is actually a 3D representation. We've got a flat field, we've got a flagpole sticking up in the air up to Q. So we're going to have to visualize some triangles in 3D a bit later on in this question, but for right now we're being asked to use the cosine rule to work out this distance over here. Now they've been generous and told us it's a cosine rule question, but even if they didn't, we would observe that I need a formula involving 3 lengths and 1 angle, and that formula has to be the cosine rule. We're going to use the opposites rule to know which side goes where. In the cosine rule, we've got a squared on one end and the angle a on the other. These are opposite in the triangle and they're opposite in the formula. So I've got x squared on one end and 104 on the other. Substituting into the rest of the rule, I've got 525 squared plus 872 squared minus 2 times 525 times 872 times cos of 104. Plugging that all into my calculator is going to give me x squared. Don't forget about the square root at the end though. So 525 squared plus 872 squared minus 2 times 525 times 872 times cos 104 is giving me x squared, which is a very great big horrible number, 1257512 point stuff. So I'm going to hit the square root key over here and cut that down to size 1121.39 meters. The convention for a lot of these questions is to use 3 significant figures, so you might choose at this stage to give your answer as 1120 meters. If it was me and I was going to use this answer later on though, I would most certainly use the exact value. So, now we're being told the angle of elevation from Q to C is 1 degree. So this is where we have to appreciate that this line is sticking up in the 3rd dimension. So we're dealing with a triangle that's sort of standing up here. The angle of elevation is this angle in here, and that's 1 degree. I'm going to draw this triangle out. I've got 1 degree down here. This length is 872 meters. And that's pretty much all I know about this triangle, apart from the fact that there's a right angle there. It now wants me to work out the angle of elevation from A to Q. In other words, it wants this bottom angle down here in this triangle. Now, this is another stepping stone question. I need to work something out about this triangle to help me deal with this triangle. The only thing they share is this distance over here, which I'm going to call h, the height of that flagpole. And on my triangle, that's h down here. This is a right angled triangle, so I get to use SOHCAHTOA. And seeing as I'm not at all interested in the hypotenuse, I know I have to use the tan part of this. So tan of 1 degree is equal to the opposite, h, over 872. That gives me h equals 872 times tan 1, and I'll work that out now. 872 times tan 1 is 15.2 meters. That's the height of that flagpole. Now looking at the other triangle on the other side, I want to know this angle over here. I've just worked out that this height is 15.2 meters. I know that's a right angle, and I know this length over here is 525 meters. Once again, it's a right angled triangle, so I'm going to use SOHCAHTOA. Once again, I don't care about the hypotenuse, so it must be tan theta equals opposite, 15.2, over adjacent, 525. Theta is then the inverse tan of that fraction. And I can work that out on my calculator. So inverse tan of that fraction is giving me an angle of elevation of 1.66 degrees. And there we go. I now need to calculate, and we're not quite done, the area of the field. This obviously has nothing to do with the angles of elevation or any of the work we did in part B. The area of the field is going to be a triangle formula. And I can see in this triangle, if we clear all that mess away, that I've got everything I need to use the area formula. Remember to look for A for area, right? That's over here. A for area. The area of the field is equal to 1/2 times 525 times 872 times sine 104. All those things from that A for area. And I'm going to go ahead and work that out. 1/2 times 525 times 872 times sine 104 is getting me quite a large answer, 222,100.69 meters squared. In the next question, I'm working out one of these little chunks of area again. Area of sector minus area of triangle. So, the diagram shows a sector of a circle. It's telling me the radius is 6. It's telling me the angle in the middle is 30 degrees. And now it's coming up with this thing which I'm pretty much going to ignore until I've had a chance to do some work. The area of the shaded segment is k pi minus c square centimeters, where k and c are integers. I'm not going to worry about this until I've actually worked out what I think that area should be. But because I'm seeing an answer with pi in it over here, it's going to be important that I stick with exact values rather than getting decimals out of my calculator. And questions like this are why I was showing you previously how to work with pi and rearranging formulas in your solutions. So let's go ahead and do it. The area of the sector is 30 over 360 times the area of a circle, pi times 36, 6 squared. That's the area of the whole sector. I now need to subtract the area of the triangle, which is going to be taken from this A for area arrangement over here. That is 1/2 times 6 squared, 36, times sine 30. So that's the area of that shaded segment. Now, if I now look at their answer, I'll notice that it doesn't have a sine 30 in it. And if you ask your calculator what sine 30 is, it's actually going to come out as 1/2. That comes out as 1/2. So my area is 30 over 360. This is 1/12 times 36. That's 1/12 of 36 is 3 pi minus 1/2 of 36 is 18 and 1/2 of 18 is 9. 3 pi minus 9. Of course, you can use your calculator to help you with these calculations. The really important thing to do is not work with pi as a decimal, but to work with it as an exact value. Okay, one more question in this video. Question 18, calculate the angle ABC. So I'm interested in this angle over here. This would therefore be a question involving two angles and two sides. I want to use the sine rule. But I realise that the problem is I don't have an opposite for the angle I want. So just as I did before, I'm going to start by working out this angle and use the 180 degrees rule to work out the one I want at the end. So sine x over 5.9, because they're opposite, is equal to sine 79 over 12.6, because they're opposite. I can churn through the usual steps and get myself a value of x, which is going to be, give me a second to do the calculation, that value is going to be 27.4 degrees. And then this thing down here, the one that I actually want, is going to be 180 minus 27.4 minus 79. And I can work that out very easily on the calculator, getting me a final answer of 73.6 degrees. More in the next video.